All right, this section is going to be section 2.3 on domain and range. Our goal is going to be to define domain and range. The second one, identify the elements of domain and range given a mapping. And the third thing, identify the elements of the domain and range given a graph. All right, so let's get started. You can either get a note sheet from me that follows this slide presentation, or you can take your own notes, but I suggest doing so. All right, so the key terms, the first one is domain. What is the domain? The domain is the set of all allowable input values. If the function is graphed, the domain is the set of all x values on the graph. So we define domain, and then we're going to show how to find it in a mapping and given a graph, just like it said in our objectives at the beginning. At any time, if you need to stop this and pause it to get caught up on the notes, please do so. So the first thing is a mapping. Here's a set of points or a relation. Let's draw the mapping. We'll put the inputs here. 2 goes to 5. 3 goes to 8. And 5 goes to -9. All right, so if the domain is the set of all allowable input values, in this case, our domain is all our x values, or the set 2, 3, 5 is our domain. Those are our input values. Now, what does that look like on a graph? Well, if you look at this graph, here's our x-axis. What values on the x-axis have points on the graph? As you can see, it's not just a single point, it's anything from here to here. So if you count 1, 2, 3, 4, 5, 6, that's -7, and this is 1, 2, 3, 4, this is 5. So any x values that are greater than or equal to -7 and less than or equal to 5, that's our domain. All x between -7 and 5. All right, let's go to range. The range is a set of a function's output values, or y values. So if the domain's the input, the range is the output. Again, if we look at a mapping, such as this right here, we can put this into a mapping. 3, 6, and 7 are the inputs, and then 9, 3 goes to 9, 6 goes to 10, and 7 goes to 5. So the range is a set of output values. So right here, the numbers in that set, the y's, the 9, the 10, and the 5, those are the range. That's your range. So what does that look like when we're looking at a graph? Well, if you look right here, your y values, your y-axis, notice there's no values down here on the graph. So the range would be all y. This is the point -4 here. And this, as you notice, goes on forever because of this arrow on the end. So all y greater than or equal to -4, all those values are in my domain. Everything from here up, because this goes on forever. All right, sounds easy, sounds good. Let's do some practice because there's going to be some tricky ones when you go to take this quiz on Apex. I'm going to ask that you be patient. Several students, most of them do fail it the first time, or they rage quit, which that's a new word, which means quitting because you get frustrated. So I'm going to ask that you not do that, but let's look at then the way to stop that from happening is let's look at this checkup. You can either print this out or come see me if you're here at school. I have some copies. So we said our goal was to define domain and range and then look at a mapping to determine it and a graph. So from this mapping, the domain is the set 1, 2, 3, and 5. Those are my input values. My range is the set over here 8. Now be careful, 12. Many, many, many students have put the 15 in. Why don't I put the 15 in? Exactly, there's not a line going to it, so you don't put it in. So make sure over here when you list the domain that you only include numbers that have arrows going from it. So the domain is 0, 1, 2, and 4. And the range would be the set 4, 6, 7, and 8. And most students are like, easy, got that down, no problem. All right, let's start looking at some of the graphs then. This is where it could get a little confusing. If you look at number 3 and we start with the domain, if you look at the graph, every single point along there has a point on the graph. It's a continuous graph. So how do we write that? We say the domain is all real numbers. Right? Well, what about the range? The range is all your y values. Again, since the graph is continuous, every single point along that route has a point. So again, the range, and another way to write all real numbers, you can do this. That symbol stands for all real numbers. Okay? All right, let's look at number 4. The domain, your x values. Because this is a parabola, and this indicates that it's going to keep going on forever and get wider and wider here, again, the domain is all real numbers. Okay? However, the range, if you notice the range, there's no points here on the graph. So the range isn't all real numbers. The range is all y. Here's where it starts. What's that point on the y-axis? All y greater than or equal to 0 is my range there. All right, we do have several more examples, and I suggest you do them with me because this is kind of a tougher quiz. The more you do, the better, the more experience you have with it, the better you'll be. So the domain here then, the x values, it's not all real because it starts here. So the domain is all x greater than or equal to -7. That's where this is at, -7. And the range, if you look at the range, because it's a parabola, and because this goes on forever and this goes on forever, it's going to keep going. The range is all real numbers. All right, now when we get to this, I have to bring up a new word. See these dotted lines here? I don't know if you've seen those before in math, but there's a name for those dotted lines. And the name is, we call those asymptotes. And what those are is, those are lines that a graph approaches but never crosses. So it's kind of like a limit. So this is going to help me out when I go to give the domain. The domain here is between these two. It's never going to go past those dotted lines. So now these dotted lines, this value is -6 and this value is at 6. So it's all x greater than -6 but less than +6. Notice I did not put or equal to because there's no point there. It's a dotted line. It's never going to touch -6. It's going to get really, 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 really close, but it will never hit it. Okay, so then my range, again, isn't all real numbers because you can see right there, there's nothing above there. So it's all y less than or equal to 7. All right, number 7, this is kind of a funny looking squiggle here. The domain, the continuous graph, all real numbers. The range, if you look at the y-axis, it doesn't go forever. It's between here and here. So if you look, that's at -2, and this is at 1, 2, 3. So it's all y greater than or equal to -2 and less than or equal to 3. All right, this one has stopping points. This doesn't go on forever. So the domain, look at your x values, are from here to here is where it goes along the x-axis. So from about here to there. So all x between -3 and 4. and the range is all y. Now this confused some students. Notice the y starts here and it goes all the way up to there. So between these two. So all y greater than or equal to -1, yet less than or equal to, this has a decimal, 5.5. I know it's been a while. We got 2 more to do. We're almost done here. 2 more problems on the next page. So let's look at these because I think they're important to go over. Again, if you note, there's an asymptote here. That's going to affect my domain. When I go to give the domain, it goes everything to there, stops, and everything to there. So it's almost all real numbers. It's actually all real numbers, but we have to add something because it isn't all. It's except, they're going by 2s, 2, 4, 6, 8, 10, so except -2. My range then is going to be, if you look, there is no asymptote there. So all along here, all along there, there's always a point. So my range is all real numbers. Again, I'm going to use blue so you can see on here, and it's on your paper, you can see the dotted lines, that there's some more asymptotes here. So if I go to give my domain, this graph is going to approach this line but never cross it. So it's all x greater than, this is 2, 4, 6, 8, -8. And my range is going to be, it's going to come to here and approach but never cross, and that's at -1. It looks like it goes between here where -2 is. So all y greater than or equal to -1. All right, so I know that was a lot of practice, but this is one of those cases where the more you do, the better. So if you're comfortable with this, you're ready to take the quiz on Apex. You're ready to take the quiz, I believe it's 2.3.3 called Domain and Range. If you need to review, just go back, replay the video, look at the worksheet. Come see me if you have any questions, and good luck.